Today I'm going to give you a demonstration of a drive system. This drive system is going to convert power from this power panel we have up here. This power panel is going to feed three-phase power into this power processing unit we have over here, and the power processing unit is going to convert that three-phase power to a variable frequency three-phase power, which is going to drive this induction machine. And this induction machine can thereby be run at variable speeds. The speed that it's actually being run at can be measured with this tachometer on top of the machine. This induction machine is going to drive the load, and this side of the setup is going to be used for the load. The load consists basically of a DC machine, and the DC machine is feeding power into another power processing unit, which converts that back into an AC, that back into the power system. So we actually have another drive system over here, and we have two drive systems working against each other, one acting as the source and one acting as the load in this case. To measure the actual amount of load that we have on the machine, we have a scale in the back that we can read the actual torque of the machine right on the scale. I'm going to give a demonstration of an open loop drive system. For an open loop control of an induction machine, the speed of the induction machine is related to the frequency supplied by the power processing unit. So we are going to adjust the frequency coming out of the power processing unit and see how that controls the speed. So we'll start off by applying 30 Hertz to the machine and look at the speed that we get. You know, it's running at 30 Hertz, it's pretty much reached steady state, and it's reading about 877 RPM in the steady state here. Now, to show that the speed is related to the frequency, I'm going to increase the frequency coming out of the power processing unit to 60 Hertz. That's at 60 Hertz. And we can see the speed went up to 1778, 1779 RPM, which is a little bit more than double, so you can see that the frequency doubled, the speed approximately doubles also. Now this has been done under a no-load condition. For any kind of practical application, we want to have load on our machine. So we're going to demonstrate the load by using the DC machine. Turning on the DC machine, you can see we have a load, bring the load up to approximately 1 Newton meter here, and we see that what happens here is that the speed of the induction machine drops slightly. This is a typical characteristic of an induction machine related to the torque is related to the slip of the machine, so the speed will drop a little bit, but the proportion of the speed drop is only a small fraction of the overall speed, so it can be considered constant speed for a lot of applications. Now we'd like to be able to show that the drive system can actually operate under a load under various speeds, so we're going to reduce the frequency of the induction machine back to 30 Hertz and see the speed drop. So we reduce the frequency of the power processing unit going into the induction machine, and we can see that the speed has dropped to 1785. We see the torque has remained the same, so we maintain the torque, but the speed has dropped to approximately half the speed it was before. Very close to the no-load speed, again a little bit smaller than it was before. So what we've done with this demo is we've been able to show a drive system can operate at various loads and various speeds.